Okay, let's talk a little bit about VSAM. Okay, VSAM, CICS and C-Trek provides well, a lot of tuning information for VSAM files. I can guarantee you that no performance monitor does this. Okay, they will provide for you the information. Some will highlight the information. Some may even identify a particular problem. The information that you can see, you're going to see in a few seconds, few minutes, that C-Trek does for you for VSAM files, you're not going to find anywhere else. Okay, so if you're not using a lot of VSAM, well, fine. This is not going to be much of an import for you. But those of you that have VSAM, this is something very important for you. Okay, and again, it applies to everything: LSR, NSR, and RLS. RLS is the tuning of RLS is more from an external point of view, to look more at the use of the coupling facility storage and so on. There's not really much outside of selecting the proper CI size and free spaces and that sort of thing can be done from tuning RLS files. It's sort of a black box. Things like, for example, strings. Well, the RLS gives you 1,024 strings. So whether you want it or not, that's the number that's allocated for you. So it's not really an issue for RLS file. So RLS, there's not really that much tuning, but there are some things that you can do, and C-Trek will identify them for you. Okay. Then LSR and NSR. NSR is something also that you don't see much information about. And even in the IBM manual, one of the things that, for example, that the IBM manual says on, for example, a performance manual, talks about what sort of files should not go into LSR. And you'll see that they say, well, a very large file where the probabilities of finding the data in the LSR pool is very low. Well, that's not true, because if you have a very large file, you probably have 3 levels or 4 levels of indices. And the indices, you're not going to have millions of records, you're going to have thousands of them maybe, but you have more probability that you'll find it in the LSR pool. And if you look at, and we'll show you this also, C-Trek will calculate for you the actual look-aside hit ratio you're getting for a file. If you look at for example, the look-aside hit ratio for let's say an LSR file, the LSR buffer pool percentage. Okay, for example, it says the 20K buffer is getting 92% look-aside hit ratio. But that 92% doesn't apply to every single file that's in there. It applies to all the files that are in there. That's the average of all the files. You're going to have some files that have 92% or greater, and some that have 92% or less. Okay, but you don't really know from that statistic how well your file is really getting, how much look-aside hit ratio is getting. Okay, but for NSR, you don't get that information nowhere. Okay, we will provide that information for you, and I'll show you how we do that later. Okay. Also, you need to look at your string allocations and so on, and C-Trek will also look at things like, for example, your defined cluster. It'll look at how you define the file, and you define it correctly. You'll see, for example, the other day I was looking at a file where the person had an 18K data CI size, and they defaulted to an 18K index size. Okay, well, unless you sit down and look at list cat, you're not going to see that sort of thing. And even in your performance monitor, it doesn't call your attention that you had that sort of situation occurring. Okay. Now, so C-Trek provides information on exclusive control weights also. You'll see that also. We'll show you a little bit later on that. And overall, there's 34 different functions that C-Trek performs for you on how to tune VSAM data sets. And if you look at it, here's what you have available to tune. Okay, now you're going to get performance monitors will tell you about buffer and string weights. Okay, but none of them is going to give you a thing that says, here you have a file defined, you have no records in there. Okay, and you'd be surprised how many files you'll find in an installation that has, especially a large VSAM file installation, that have no records installed. We'll leave the LSR pool a little bit later. We're looking at I/O activity. The one I'd like to see is this one, the G, the files EXCP analysis. This will tell you the look-aside hit ratio of the individual files themselves. It'll take a 10-second look, and it'll tell you, okay, this particular file, which is an NSR, is getting 40% look-aside hit ratio. Or this particular file, which is an LSR, is getting 92% in the data and 95% in the index. Okay, so you will actually be able to see of each by file how well they're doing versus on the LSR pool statistic as how well they're doing themselves. We'll be able to see information about the LSR. Here are two important ones here, for example. The index CI size analysis. Okay, one of the things that you don't know and you won't see unless you sit down and analyze each file individually is if you have a key compression problem. A key compression problem, what it means is when you have a CI size, you can put in there X number of indices. If the CI gets full before all the CIs in the CA are used, then what VSAM does is very simple. It goes to the next CI and leaves all the other CIs, data CIs, as free space. Now, that's not an easy thing to recognize as getting that condition. But CTREC will do an analysis for you and will identify those files that have the potential for having key compression problems. So you can basically, instead of having, let's say, a 2K index, you increase it to 4K, okay? And that sort of thing, okay? It also gives you the index distribution. This is a very important thing if you're going to tune NSR files, okay? It'll tell you, okay, this file has 2,000 indices, but how many of them are sequence set index, which is the lowest level, and how many are index set levels, which is the second set and above. And you can see that analysis within CICS because, or within CTREC, excuse me, because that number of second level and higher indices represents the number of buffers that you have to add to the file to be able to get good look-aside hit ratios for it, okay? Again, you have the key compression problem that I just mentioned, which is you're going to see in two places. That one will identify the files themselves. You'll see things like, for example, NSR. You'll see files that are over-allocated. You'd be surprised. Files. You'll see a person say, I need 2,000 cylinders. And all of a sudden, when you look at it, it's only using 100. Okay? And that sort of thing will provide it for you. We'll do that analysis for you. You'll be surprised also how many files have not been updated in over 30 days. We see files that have been in the system, sitting there, and that are years old and have never been updated. They may be referenced. That's something you have to look at. But many times these files are just there because somebody forgot to eliminate it, and they say the JCL. Okay. It tells you files that should be suggested for reorganization. Okay. Things like, for example, files that are under-allocated, you're generating too many extents. VSAM file exceptions, we'll see this display a little bit later on. Okay, you know, how your data table's working, you know, are they working well? What is the look-aside hit ratio? How much are you doing any I/O to the data tables, which is bad. You shouldn't have a data table that has less than 90% read operations, okay? Things, for example, RLS files, how they're defined and what their look-aside hit ratio is, okay? And things like, for example, what files do I recommend, you know, that could be a data table. Data tables are, if you have a lot of files that you can put them as data tables, you really improve your performance quite a bit because it reduces the amount of CPU time that you require to find the record. And in addition, it's also faster. So you get better response time. So many times people don't, you know, they look at a data table, you know, because they say, oh, it's a file that I can access. I access quite a bit. But in this case, you know, they don't look at the fact that, you know, maybe I don't have one that can access that much, but I could put them as a data table and at the same time get better performance. Also, you have a string analysis. One of the things that you find is string information in CICS is very simple. If you're in LSR, okay, if the file's in LSR, it'll tell you if you have a short on string type of situation. And it'll tell you the maximum number of strings that are used in the pool but not for the file. So if you have a file that has 30 strings and the pool has 100, well, if you exceed the 100, you'll get a message. And if you exceed the 30, you'll get a message. But you don't really understand that that 30 is over allocated. Okay, and if the 30 is over allocated, you're wasting, resources, especially if it's an NSR file. LSR, that's just a number. Okay, CICS doesn't use it as such. Okay, so these are some of the things that you have. And again, it does the analysis of all the data sets that you have there defined as VSAM. And just to show you a couple of the displays, okay, now on the LSR side, as I mentioned, remember, there's 28 different CI sizes in VSAM, and only 11 of them are defined in the LSR pools. The interesting thing is RLS has a better distribution. RLS uses 2K instead of the normal 4K, which that LSR uses. In other words, in LSR, you have half a K, 1K, 2K, and from there on, it's in blocks of 4K, 4, 8, 12, 16, all the way up to 32. In RLS, you have, the same thing, half a K, 1K, 2K, but from there on, it's 2K, 4K, 6K, 8K. So fragmentation is less of a problem in an RLS file than it is a buffer fragmentation than it is in an LSR environment. And now, the recommended guidelines for that you should use for the data and for the index to know that you have sufficient buffers allocated and so on is 80% for the data. In other words, 80% of the time you should find the data in the pool, in the buffer, okay? And 95% of the time you find it in the index. Then the index is found in the buffer. And a combination of both of 93%. What it basically is saying is that if you do 100 accesses to the disk, okay, 100 accesses to a file, 93% of the time you should find the information in memory, and you don't have to go out to the disk. Remember that an I/O costs you two things. It costs you about 10,000 instructions, CPU instructions, and it costs you a state change. A state change is very important because a state change basically is things like the translate look aside buffer, your cache that are out there. Well, you went from CICS to the master scheduler. The master scheduler has different addresses, has different areas, and so on. So all those buffers that you have built in to give you, the proper MIP type environment have to be repopulated. Okay, so you need to get all that's required in there, and you lose. For example, if you have a 100 MIP machine and you have like a Z14, you probably go from 100 MIPS to 92 MIPS until you repopulate the buffers. I mean, the translation of the side buffer and all that stuff. If you're in a Z16, it's probably down to about 97 MIPS, 96, 97 MIPS. So the newer machines are better as far as the state change occurs. But notice that when you have a state change, your velocity goes down, okay, on the machine. That's why you hear a lot of people talk about that the MIPS are meaningless because you don't really get 100 MIPS on the machine. So that's because whenever you have a state change, you have to repopulate the buffers and so on. Yeah, but it's still one of the measurements that you use. And these percentages I mentioned, 80, 95, and 93, are dependent on installation. Some installations are more strict and they want better performance. Others are not as strict and have less. Some really don't care. Some don't even look. Using C-Trek, we have found that clients have been able to save anywhere from 3% to 15% a CPU, CICS CPU type. The 15% are the ones that really didn't do much tuning. Okay, the 3% are the really gone wild, they like to do all the tuning all the time. But even then, there are a lot of things that you don't see because the monitor doesn't identify it as a problem. Okay? And the main objective that you have with LSR is to reduce the overall physical I/O activity. As I mentioned, physical I/O activity consists of two interrupts, two state changes, the SVC to go from your CICS VSAM area or DB2 area, it doesn't matter, okay, into the operating system, and then the I/O interrupt that occurs when that record is found and brought back into memory. So you have two state changes, and you have there's a slight cost there and so on. And that is why you'll see that IBM will, like in a multi-processor environment, will allocate only one CPU at the very beginning to handle I/O interrupts. And with that, they also have there's a parameter called CP enable. And normally it's defaulted to 10/30, 10, 30, 10% and 30%. And what it does basically, as you switch, you work with these percentages, it'll activate a second CPU or a third CPU to handle I/O, depending on how much volume you have. That's really. But the important part here, and something which I stressed, is the idle or unused virtual storage. Okay, the idle or unused virtual storage is something which is interesting. You will see an installation that has a good 80% on the data and a good 95% on the index and a combined of 93%. And you will see that they have 800 meg of storage available. Okay, and then you will also see that they don't have a paging problem at all. But when you look at these places, like for example, especially if you leave these your CPU, your CICS system goes more than 1 day. You don't recycle them often. I've seen installations that don't recycle CICS for months. Okay, when you start looking, you see that even though they're getting a 93%, they're still doing 1 million or 2 million or 3 million physical IOs, and they have 800 meg of unused storage, idle storage. What use are you getting out of that? Nothing. Okay, so what do? We say, hey, allocate more buffers. Having more buffers is not going to kill you as long as you don't start paging. Okay, you put those buffers in there, because if you put those buffers in there, you eliminate I/O. If you eliminate I/O, you reduce your CPU utilization and you improve your response time. So do not have idle or unused virtual storage unless it's, there's really not much more that you can get out of the system on that. Okay. Okay. So here are some of the hidden things that you will not see with any performance monitor. Okay. The first one is buffer monopolization. There's no statistic available from CICS, okay, that tells you how many buffers in an LSR pool is the system using. Okay, is a particular file is using. Okay, so the only way that you can say that a particular file is monopolizing a particular buffer is you say, oh, look at this guy. He did 2 million reads. Okay, he's the guy that used the most buffer. I mean, he's the guy that used the most XXCICSs. That doesn't mean that he used that many buffers. Okay, because the buffers depend on what he's reading. If he read the same record over and over and over from different tasks that are executing, it doesn't reflect that you're monopolizing the buffer pool. Okay. Again, you also don't know what CI splits are causing. How many buffers do you have out there that are really only 50% full? Okay. In addition, you don't see what the effect of buffer fragmentation. And when I talk about this particular buffer fragmentation, I'm not talking about having the 10K CI size and you forgot to define a 12K buffer in the LSR pool, because that is bad. You should fix that. What I'm talking about is you have an 18K CI size and you're using a 20K buffer. Because remember that it's in 4K increments after 2K. Okay, so what's happening is you have a 2K fragmentation. That's acceptable because 18K is the best CI size for a track utilization. You can fit 3 18K records, okay, in a 56K track. And it gives you like 97% utilization of the track. Okay, so it's the best track utilization size that you can use. Okay, however, that's only good for normal VSAM. because you have VSAM extended, okay? In other words, you're using extended addressing and so on, that file is defined through SMS, okay? Then the problem is that VSAM will not use an 18K block of physical record size. It'll use 3 6K record sizes, which lowers it to 87%, the utilization on the track, okay? However, going back to that 18K guy, okay, and the 20K, the normal thing, you're getting a 10% fragmentation, okay, no problem. But a file has 100 buffers. It's using 100 buffers in the LSR pool, so it has 200K worth of fragmented storage that's losing. That's real and virtual storage, okay? But what happens if that file has 4,000 buffers times 2K? That's 8 megabytes of storage that's being lost, okay? So in many cases, it may be better to raise that file from an 18K CI size to a 20K CI size so that it uses the complete space that's out there, okay? But you don't know how many buffers a particular file is using because you don't get that statistic from CICS, okay? So you need that sort of information you will get from C-Track, and I'll show you that in a second. Okay, this is one of the screens. This is from 6.1. And again, remember, we have a very low activity type file. Here you have the information says, hey, I'm back now. Okay, so I can continue. Okay, thank you. I just got the volume because apparently our friends here on the telephone line. Okay, thank you. Hello. Okay. Sorry, apparently we lost the connection there for a few seconds. Unfortunately, we live in an area that has a lot of construction going on. You know how it is. People from these things, they do things that the telephone lines they're not supposed to do. But anyway, this is the display of the file buffer allocation for, in this particular case, for LSR pool 1. And it says, okay, I have the 32K buffer here on the right-hand side. I have 6 buffers defined. Again, as I mentioned, if you wanted to see the control block that handles this buffer, this is the address. If you put your cursor here and hit PF5, it'll take you to that control block, so you can take a look at it if you're interested in that sort of thing. It tells you you have 6 buffers. It represents 196K worth of storage. Okay, you've hit 466 times, and that sort of thing. Normal information you get from your statistics. But of those 6, you're now using 50% of them. Okay, now what's happening is you have this file called C-Track AHF, which is using 3 of them. Okay, so he's using 50%. Now with this, in a normal installation, you will see a list of files that are using the 32K guy, and you will be able to see who is really monopolizing. Now, 50% may not be monopolizing as long as the other guys are getting, their buffers are getting good response time. We'll see how we can tell if that guy's getting good response time or not. Okay. But anyway, this is the sort of thing that you can find. And then you can also say, okay, I want to see these 3 buffers. Okay. So you put your cursor on it and you hit PF4. Okay. And you will get, these are the 3 buffers the person has. Okay. One of them is active at this point. If you have a PLH, that's placeholder, is what that control block is. If you have a placeholder there, that means that that particular CI is being used in the buffer. Okay, it gives you what the character format is of the thing. If you hit PF11, you go over to the right, and you'll see it in hexadecimal. Okay, and very important, it tells you how much free space do I have at this point in that particular CI. This one and the third one, I have 16K and 26K of the 32K is empty. So these are candidates for being CI splits. So I found out number one, down here at the bottom, I have a total of 3 LSR buffers for this file. 2 of them are CI splits. That's 67%. Okay, so that means basically that this file I should look at, how my CI splits are happening. Do I have the proper free space allocated? If not, should I reorganize it more often? And take a look when it was the last time I reorganized this file and so on. Okay. Also, you will see this information for this particular file. Because it's a 32K file and the buffer is 32K, we're not going to have any fragmentation. But if we did have fragmentation, it's going to tell you what the storage cost is going to be. Like in that case that I mentioned, that you had 100 and you lost 2K, you would have 200K here. Okay, and it'll tell you what percent of it is. Okay, so this is where you would be able to also find whether you have a file that is has a normal fragmentation, but you should basically, in a sense, be able to, to say maybe I should increase it from 18K to 20K, so I don't have any. I can get better use of that virtual storage and that real storage. Okay. Any questions on that? Okay. And it gives you some information. It says the CI size of the file is 32K. That's why it's using a buffer of 32K size. It has 41 splits, okay, and it has 1 active buffer. This is the active buffer. Okay. Any questions? Okay. So, if you are interested, I mentioned at the very beginning, if you're interested in getting more information on how to tune your LSR, you can use this entry here, the Enterprise Tech Journal. On page 12, you'll find this article which I wrote. Okay, and gives you more details and so on. I don't show the C-Trek displays that you would use to be able to tune the particular area. But if you do get the documentation from C-Trek in the appendix, and I'll show you that at the very end, you'll get the article and it'll show you the C-Trek screens where you can get the information to tune the LSR. Okay, now here's some of the things that are very important. As I mentioned to you, IBM doesn't provide, and I don't think I've seen any of the monitors provide, what the look-aside hit ratio of a file is, except for LSR files. And what they do is they use the buffer look-aside as the look-aside hit ratio for the particular file. And remember, the 20K buffer having a 90% look-aside hit ratio is not what my file necessarily is getting. My file may be getting higher or lower than that 90%. Okay, now C-Trek will take a 10-second look and will give you an estimated look-aside hit ratio. In this particular case, these are the files that were active. Okay, and this is the look-aside hit ratios that you're getting. In this particular case, this one called ampersand Bill issued 84 exec-CICSs. Did not do any EXCPs, so therefore he has 100% look-aside in the data and 100% look-aside, this is the data, excuse me, and there's 100% in the index, okay? And he's an NSR file because he doesn't have any look-aside in there, okay? So he's doing very well. This one, okay, is only doing 25% look-aside hit ratio because it did 84 exec-CICSs and it resulted in 253 IOs, physical IOs, okay? So you look at it, it's almost like 3 times the amount that you're getting. They took 25% there, it's doing 1% in the data and 0% in the index, okay? And again, here you see an LSR. These guys are in LSR. He's getting 100%, but the buffer is only getting 99.5 and 97. Okay, so again, this is one where the guy's above. Here's another NSR file. He's getting 15%. What we have found is that you should move your files out of NSR into LSR. We have found that on the average, NSR gives you between 40 and 60% look-aside. Okay, while most LSR files get somewhere between 90 and 95%, okay, in look-aside hit ratio, okay? So, this is something you would look, and this is something that you could do, every day. You can take a look and see how your files are, okay, how they're doing and so on. And you just hit the enter key and it'll go out and do another 10-second analysis. Okay, here's one where, remember I told you about the index record distribution. Okay, now I will, let me see if I jump one here. So I can go backwards here. How to do that. Okay. Okay, now, this one basically what tells you is, okay, this is a file called, let's say, EDR1, okay? An 18K CI size of 112K index size, CI size. It's an NSR. It has a total of 115 index, of which 5 of these are second level and higher. And this is 120 of them. Now, why is this important? Because if this file, like it is in NSR, because it has 0, okay? No, excuse me, it's open. It's in 0 in the pool. That means it's an NSR file. And that means that I have to have at least 5 additional buffers when I define the NSR file to get a good look-aside hit ratio. Okay? And we'll see that a little bit later. Okay? This is another one of the important things that you'll see is you can ask, I want to see the top 100 files with CA and CI splits. And it gives you, this is the files. When you see a guy that has a lot of splits in the CI and he's in NSR, then you say, ooh, excuse me, in LSR, then I have to take a look at that file because I may have some buffer fragmentation as a result of the LSR pool being, excuse me, because of the splits using only 50% of them. Okay. Questions? Okay, so this is another one of these places you'll be able to see. Okay, this is an analysis of the VSAM defined cluster. Okay, it'll go out there and say, okay, I'm going to look at these different files. And for example, payroll has 2 messages. It has a bad control area size defined, and it's a bad track utilization. 1024. You're probably going to get around 50% utilization of the track. In other words, you're wasting 50% of the space. Okay, so again, if you were doing this with Omega Mod on one of these files, you would have to physically go look at each individual file and see, how it was defined and go through that. And when you look at that, which I told you, the main thing that we did at C-Trek was to try and make this the fastest way possible to tune the system, okay, and to identify problems and so on. Okay, so it has all that. The control area size controls how many second level indexes you get. Okay, that means that this guy has 111,900 and been defined in track 8. The primary was 8 tracks. Okay, those are bad definitions. Okay, questions? Okay, here's for NSR. You basically, it goes in and takes a look at all the NSR files. Now these are all closed, that's why they're in blue. Okay, but this one here, codes, says I have 3 buff NDs and 3 data buffers. I have 1 string. I have 3 buff needs, and you really only need 2. Okay, you don't need that many buffers, but that's not really important. It's not in yellow. It's not a big thing. However, this guy says I have 1 string and I have 3 and 3. Okay, and it says, hey, you should have 6. Now remember this guy here. The look-aside on an NSR file is done in each string needs a buffer, an index buffer. So if I have one string, it says it here also, and I have 3 buffers, it says you should have 6, because I'm only going to accommodate 2 other second level indices as such. Okay, And if you look at this file, okay, this is the file we looked at before, you'll see that he has 5 additional guys in the second level. Okay? So you look back here, he says you have 1, so you need 1 for the string, 1 index buffer for the string, and you need 5 additional ones. That's where the 6 comes up from. Now, how do you get these numbers? Well, if you didn't have C-Trek, you're going to have to sit there with a calculator to calculate how many of these index buffers exist. Okay? You would have to take, and the formula is very simple. You take the number, you take the number of the high used RBA number and divide it by the CA size in bytes. Okay, and that gives you the total number of index records you need. Now, you take that total number of index records that you need for the sequence set and subtract it from the statistics, and the difference between those two is the number of second level indices that you have. Okay, and again, you do this analysis, all the files at one shot. Okay, and it'll highlight it for you, those that need attention. Okay, and again, if this is a very active file, you're going to improve reducing the CPU and improve its response time.